Well, our next presentation is on identifying and verifying Bankfull, so we'll walk through this. I just want to kind of start with an acknowledgement that just about every major stream assessment method in the United States uses Bankfull in some way. So the Bureau of Land Management, BLM's Assessment, Inventory, and Monitoring Strategy, or AIM, uses Bankfull. NERSA uses Bankfull. The EPA's RBP, the Stream Quantification Tool, obviously, SVAM, USGS's National Water Quality Assessment Program, and more. Like, I just sort of did a snapshot and was looking through manuals, and all of these point to using Bankfull in some way. And for the stream functions pyramid framework and really the SQT, we use Bankfull as a way to normalize data. So it really is a form of regionalization. And then the second is that there are a few parameters that do include Bankfull. So floodplain connectivity, bed form diversity, large woody debris, and lateral migration all include an understanding of what that Bankfull feature is. I also wanted to point out that almost all design approaches also point to Bankfull. So natural channel design is probably the one that's most recognized as being built around the concept of Bankfull. But even some of the process-based approaches still point to Bankfull in their user manuals. So the low-tech process-based restoration of riverscapes, this is a lot of the Beaver Dam analog work. If you look in those user manuals, they are referencing Bankfull. Even a book called Let the Water Do the Work. Again, there are references to Bankfull in that document as well. And then analytical approaches like modeling approaches, some of those also reference Bankfull, but many of them just make the 2-year discharge equal to Bankfull, which is typically not the case. So these approaches do use Bankfull in different ways, but I just wanted to kind of start this presentation with this concept and utilization of Bankfull is ubiquitous across assessment methods and design approaches. All right, so the challenges that we have is first and foremost just a lack of experience identifying and verifying Bankfull. And I kind of will go back to a comment I made earlier where even though our intention is that only people who are experienced in these assessment methods will be using the SQT, that's just not the reality. We get a lot of people, from the wetland assessment and restoration field who move over and kind of immediately want to do the SQT. We also see a lot of just people right out of school being given the responsibility of doing the SQT. So they may have a degree in environmental science or biology, and suddenly they're sent out here to do this work, and that is leading to some repeatability issues. Of course, we have the challenges in disturbed streams, like is there even a Bankfull feature there? And then in Wyoming and Colorado, and just the states out west in particular, we have the challenges of regulated watersheds. So we are increasingly working as hard as we can to make this process more defined and more repeatable, and trying to help people who don't have years of experience doing this to kind of catch up. So I'll just start quickly with some definitions. So Bankfull fits underneath this theory of channel forming discharge that just notes that it is a theory that there's this unique flow, so a single flow that over a long period of time would yield the same channel morphology that is shaped by the natural sequence of flows. So this Bankfull discharge, or the idea here, is that you could size a channel off of this one discharge and get the same answer as if you analyze the full range of flows and what its impact would be on the central tendency of channel size. There are generally 3 types of channel forming discharge theory. three terms that are often used. One is dominant discharge, which is not very useful. It's just short term for channel forming discharge. There's effective discharge, which is the most quantitative, and then there's Bankfull, which is the most field-based. So that's the reason that we use Bankfull more than effective, is that we can go to the field and find these features. So Bankfull discharge, it fills a stable channel up to the elevation of the active floodplain. So I'll put that in quotes. That's kind of a key thing to remember. Fills the channel up to the active floodplain. My favorite definition of Bankfull discharge is the second bullet. It represents a break point between processes of channel formation and floodplain development. So we think of the channel formation process. That was a sediment transport process, at least at some point, or there would not be a channel. So if you think about the channel from that perspective, like a sediment transport process, and then the break point is the break between a transport process and a depositional process. So that would be the floodplain component. And then it does leave a mark. So we can go to the field, identify Bankfull, and record our measurements. All right, so how do we do that? So I'm going to kind of walk you through really the 3 steps that we outline in the user manual for finding Bankfull and really verifying it as well. So first is to look for those indicators, and as you do that, measure the difference between your Bankfull and your water surface and look for that consistent difference. 2 is to measure the Bankfull cross-sectional area at a representative or stable riffle. And then 3, to compare your cross-sectional area to a regional curve and really answer the question, does that point fall within the range of scatter? So I'll walk us through all 3 of these steps. So first is your Bankfull hunt. So step 1, go out into the field and find Bankfull. And really you want to try to identify 3 features. You may not always have all 3, but look for them. So there often is an inner berm, then there's a Bankfull feature, and then there's a terrace. So the terrace is the abandoned floodplain. This is obvious in systems that have naturally incised or have incised because of human impact. And again, just want to reiterate, this really is not an activity for someone without experience. So when you get out into the field, this is from Wyoming. This is actually a restoration site, and they're checking the top of bank. And so they're saying, okay, well, top of bank might be Bankfull. So they're laying this survey rod down at the Bankfull stage, put a little line level here to make sure this rod's level, and then putting the rod right here at the water surface and measuring that difference between the water surface and the rod. And then you want to make that recording. So you want to say, okay, top of bank has 1.5 feet above water surface, and see if the other top of banks are about 1.5 feet above water surface. Maybe you see a feature that's lower than that and you suspect that's the inner berm. Then make those recordings. But it is very helpful if you'll record the feature and then the range of values for that difference in water surface and the feature that you're looking at. Here's a point bar. So this is a depositional feature on the inside of a meander bin, and it's pretty common to see point bars have these 2 breaks. And it's very often that this first break is what we call the inner berm, and it's the upper break that really is that separation between channel forming flows and the floodplain. So this would be more likely to be your Bankfull feature than this first break and slope. And again, we want to measure the difference in water surface and that feature to see if maybe it corresponds well with the top of bank upstream. Here are just a few other examples. This is another point bar. You can see the streams coming this way. So this is a scour process, and then the point bar is the depositional process. I like using point bars as bankful indicators because I know that point bar was built by the river. And this particular point bar has a slope all the way like this, and then here's the break and slope. And so bankful is that break and slope. These folks are all sitting right over here. And I kind of zoomed in because you can see the change in grain size. So right at this bankful feature, where it breaks from the channel to the floodplain, we also see a change from gravel that was transported by the river to sand, which is being deposited on the floodplain. So for those of you that are working in urban streams, you know, it can be more challenging. These streams are evolving, but more often than not, we can find a bankful indicator in these disturbed landscapes. In this example, you can see these benches that are forming on both sides of the stream. So this channel incised, it eroded, and as it's eroding, it's depositing material into the channel. That material begins to form a new floodplain. I like to call it a juvenile floodplain. Sometimes it's a bit rowdy. It's like that rowdy teenager. And often this feature will have a slope to it. It will not be flat. And when that's the case, often the front of the bench is your inner berm and the back of the bench is bankful. Now, over time, those benches generally get bigger and bigger, especially if you just let the river do its thing. And so when that happens, that feature will flatten. And when the feature flattens, and this isn't a great example of it, but often trees will start to grow on this bench as well, then bankful moves from the back of the bench to the front of the bench. And in this example, we still have a bit of an inner berm, and you can see the terrace. So all three of those features nicely displayed in this picture. You know, my favorite picture again, and it is easier for many of these systems than in Wyoming because of the vegetation. Like you show up here and you already know that you need to get down close to the channel to identify bankful, and most likely it's going to be top of bank given how wet this floodplain is. Here's a more arid landscape. So this is in Arizona. This is also a stream that has incised, a bankful bench that has flattened out. You can see the trees are starting to form. So in this example, bankful is right here along the top of this bench. Here's an example from Rocky Mountain National Park where there really are no features other than top of bank. So top of bank here is bankful, and this meadow is very wet. As you walk across this, it's a single thread channel, but it is a stream wetland complex as well. All right, so what about this? You get into the urban stream and there's a concrete line channel, like where's bankful? Well, this is an example that you do not have a bankful indicator in this reach. If it's not there, you don't have to make it up. Now, you can go downstream, get away from the concrete line channel, and see if there are bankful indicators downstream that could be moved up into your reach. But if not, then we'll show you towards the end of this presentation. We have a flow chart to help you work through this process and give some guidance on what you can do if you do not have bankful indicators. This is another, both of these are obviously flood control channels. This is one that has not been maintained. You can notice in both of these flood control channels that there are grading. That always happens with flood control channels because they're oversized, and all of the smaller and intermediate floods do not have the sediment transport capacity to transport the load, and so they tend to accumulate with sediment. They require maintenance. In this particular example, they have not maintained it for a while, and so there is a bench that is beginning to form. So you might have a bankful indicator here, but it would be one, again, that you would need to verify in order to use. All right, so this is step one, is looking for those indicators, measuring the difference between water surface, between bankful and water surface. I just want to make one thing I'm not going over in this presentation, but I want to point you to the user manual to find, and that is when you do have those benches and those benches are sloped or flat, we do give guidance in the user manual to help you determine, is Bankfull the front of the bench or the back of the bench? And then where is the top of low bank? So this becomes really important when you're doing that floodplain connectivity parameter, is knowing when Bankfull is also top of low bank, if it's a bench, versus when top of bank is the next feature up. So I'm not going to go through that here, but do go check that out in the user manual. All right, so the second step is to measure the Bankfull cross-sectional area at a representative stable riffle. And there's two ways to do that in the user manual. There's a rapid/coarse way to take your measurement, and then there's the detailed way. The detailed way means you're going to use survey equipment to do that, like a laser level or a total station. The rapid method means you're just going to pull a tape, get that tape level, take some depth measurements, get a quick cross-sectional area, just that width times your mean depth. That is sufficient for doing just Bankfull identification and verification. But once you have finished that process, you do want to go ahead and survey a riffle to be your final representative riffle. And then once we do that, once we have that cross-sectional area from our representative stable riffle, we can compare it to the cross-sectional area on the regional curve and answer this question: does the point fall within the range of scatter? So here's what we're talking about. So here's a regional curve. So we have all these points that we've collected from streams where Bankfull was top of bank. There's no question about what that Bankfull feature is. And then the black line here is the regression equation. You can see that equation here on the bottom right. And then these dashed lines in this case are the upper and lower confidence, 95% confidence limits. That's kind of the ideal. If you have a regional curve that does not have confidence limits, you literally could just take a ruler and draw dashed lines kind of at the low end of your scatter and the upper end of your scatter for these purposes. That is not statistically valid, but for practical purposes, it will work for what we're trying to do. And so what you'll notice is that if you hit the inner berm, most likely you will be below the range of scatter. If you assessed Bankfull, then you should be within this range of scatter. Maybe not right on the line, but within the range of scatter. And then if you hit the terrace, you're going to be above the range of scatter. And I'll note that typically a terrace is way above the line, like you may be way up here. People generally don't get Bankfull wrong by measuring terraces. People more often get Bankfull wrong by measuring the inner berm. Again, especially if they're coming from like doing ordinary high water mark assessments for jurisdictional determinations, they more often than not are too low and they get this inner berm. So this method, I think, more than anything else, will help us get into to improve our repeatability. And then, let me see if I have that. Yeah, so then the question is, what if both features fall within the range of scatter? If that happens, just by rule, we're saying use the one that's closest to the regression line. We're not saying that's right or wrong. We're just creating it as a procedure to improve that repeatability. That way, we should all be getting the same answer. Okay, so for all the modelers who are out there, we do want to acknowledge that H&H models can play a role in doing Bankfull verification. The problem is that sometimes modelers don't want to go to the field and look for these indicators. They just want to run computer models from in the office. And so we don't recommend that, but we like using these models to further verify the Bankfull features. So, and then you can also use them in streams either without Bankfull indicators So this part, they really can be an aid and supplement the use of regional curves. And then here, again, I'll show you some techniques we can do if we don't have Bankfull indicators, like those urban concrete channels. All right, so we put this flow chart together first for Colorado, and then Wyoming kind of adopted it into their current version. For those of you that are outside of Wyoming and Colorado, we actually have an updated version of this flow chart. So if you're working in Wyoming and Colorado, use this. If you're working in other states and you're curious about what the newer flow chart looks like, you can let me know, and I have another PowerPoint that kind of shows a different version of this flow chart. But this is what we will use in both Wyoming and Colorado. What we just went over was essentially method 1, and these are in priority order. So we recommend all practitioners start with method 1, which means you're going to go to the field. And this is the scenario where you have Bankfull indicators present and there's minimal flow alteration. All right, so if you have that, then you're gonna go to the field. You're gonna identify your Bankfull features, which we just talked about. You're gonna measure that cross-sectional area. You might get slope and bed material, so you can also do a discharge estimate. And then you're gonna ask the question, do we have regional curves? If you do have regional curves, you'll come down here and then plot your data on that regional curve. And if it plots within the 95% confidence limits or that range of scatter, you are verified. If it is not, then you repeat the process for another feature. If you find your feature and there are not regional curves, then it kicks you over here to method 2. You also get kicked over here to method 2 if there's minimal, if you do have some flow alteration in your watershed. So you have Bankfull indicators, but there is this substantial flow alteration. So now the first part's the same. You identify your feature, you survey your area, get the slope, sample your bed material, and now this is where the modeling comes in. So you have to use those, H&H or USGS regional regression equations and HEC-RAS to develop a flood frequency analysis and determine that 1 to 2 year return interval, and then find out, does your Bankfull discharge that you're estimating up here, is it under that 2 year? And if yes, then we can say it's verified. If it's no, again, you can repeat the process for the other indicators. And kind of here, if you go round and round with this and it's not working, then that kicks you to method 3, which is basically you don't have any Bankfull indicators present. But note with method 3 that you've already worked through method 1 and method 2. You can't just not go to the field and say that you don't have Bankfull indicators. So from here, you still have to have cross sections and take your slope measurement and your bed material. And then if you have regional curves, you can put the Bankfull discharge into that cross section and estimate your Bankfull dimensions. So you'll be using that regional curve plus HEC-RAS, for example, to estimate your Bankfull width, mean depth, max depth as well. If no, then you're going to use your H&H models to estimate a 1.5 year discharge. You're going to assume your 1.5 year discharge is Bankfull. Put that in your cross section, and then you can get your width, mean depth, and max depth. So we've laid this out, but 90% of the time you should be in method 1 and method 2. And one of the things that's not nuanced here is that you could use method 1 in a watershed that has flow alteration if you develop a watershed specific curve for that watershed. So these are some of the nuances we're kind of working on in newer versions of the flowchart. All right, so I'm going to kind of walk through method 2 a little bit more, kind of give you an example. So again, you're going to use this if flow alteration is evident. Regional curves might not be available. And you can also use it to further verify method 1. So for example, let's say we get here and the point is falls within that scatter. You could also do a flood frequency analysis to confirm that the discharge is also between that 1 and 2 year return interval. So just kind of an example, this is from Wyoming. You know, you've got it looks like you have 3 features that are quite prominent here. Here's the inner berm. This looks like Bankfull. This looks like a terrace. But then we walk upstream and we see that there are flow diversions. So it's like, well, is this in fact still Bankfull, or might it be a terrace because of the flow alteration? So we plot, we do our cross section, and we determine that for this feature, the cross-sectional area is 60 square feet, which then from our slope and bed material, we can estimate a discharge at Bankfull of just, for example, 180 CFS. So then we can go through the flood frequency analysis, and you can see most of those, if you just pull this from USGS or something, usually they're going to start at a 2 year. So we can see the 2 year here is 243. If we plot this and extrapolate it, we can see that the 1.5 is 193 CFS, which is very close to that 180. So since they are so close, and since the 180 is less than the 2, then we can verify that feature that it is still Bankfull, even though there's a diversion upstream. So a couple examples of sites where you should test method number 2. I showed this one before, like, yeah, maybe this is a Bankfull feature. It looks like it could be, but it's not that old, so you don't know if the feature has really built all the way up to Bankfull. So you could start with this break and slope, but then go through that flood frequency analysis to confirm that yes, it is Bankfull, or no, it is not. And then here's a shot from near Denver. You know, it looks like a really nice stream. It is a pretty good stream. It's got at least kind of this bar that's forming. You know, it's like, is this Bankfull or is this Bankfull up here? It's hard to say because there's a lot of flow alteration in this watershed. So this is where you would want to use method 2. And I will just point out this one also had a watershed specific regional curve. So that is a tool that you can use in these altered watersheds, is just to develop a watershed specific regional curve for that watershed and use it in conjunction with the modeling that's in method 2. All right, so then we're left with method 3. As we mentioned, no indicators present. And in the user manual, we do ask for proof. So go out there and take pictures so we can actually see that, in fact, there are no Bankfull indicators present. I say we, I really mean like the Corps and the IRT, the regulatory agencies. And justify that methods 1 and 2 did not yield a verification. So we don't want people just jumping right to method 3 without full consideration of methods 1 and methods 2, or methods 1 and 2. All right, so these are classic examples of streams where there is no Bankfull indicator here. Yeah, there's some deposition here, but it's really low. It's not consistent. Both of these, these are going to be your really urban flood control channels. So when that's the case, if you have a regional curve, you can use the discharge from that regional curve. If not, you're left with the hydrology and hydraulic models. And here's kind of what that looks like. So again, if you have the regional curve, you can use the Bankfull discharge from the regional curve. If not, you're going to have to do a little bit of hydrology work to figure out, is it the 1.5 year discharge, and then put that into HEC-RAS or another single section analyzer to calculate the dimensions. So here's that cross section, and you're basically just putting that water into this cross section. You can see it was designed to carry the 100-year flow event. So Bankfull is way down here, has a discharge in this example of 44 CFS. That's like the independent parameter that's put into this model, and then the model will calculate the width, the mean depth, and the area. And so for SQT purposes, you need this width for some of those metrics. Actually, you need the width and the mean depth to assess several of the metrics, bed form diversity, for example. So you would get this from a modeling result. If regional curves are not available, then you're going to use that model to estimate a 1.5-year discharge, put that into the channel. So for example, you might have 193 CFS, and then that could yield an area of 35 square feet, 29 feet wide, and 1.2 feet deep. And just know that this is not verification. You have not verified Bankfull at all. You've just used a modeling exercise to estimate Bankfull. So this is best used if you can't do other verification processes, and really best only used to further predict impacts. All right, so in conclusion, just want to let folks know that there is a Bankfull verification form that needs to be completed with the SQT submittal. And then Appendix D in the user manual includes a Bankfull verification checklist and an example. So we're trying to beef up the user manuals with more assistance in the Bankfull identification and verification process. And that is it.